Welcome back, Prealgebra students. We are in lesson 73. We're going to talk about right circular cylinders today. So we have already done the area of a circle, and we know that the area of a circle is pi r squared, right? Well, the volume, we know volume with a cube or a triangle or whatever it might be, is the area of the base times the height. So if the area of the base of a circle, of a cylinder, is a circle, then the volume of the cylinder, which has a base of a circle, is the area of the base, pi r squared, times height. So this formula right here gives you the volume of a cylinder. So for this particular cylinder, we have a diameter of 2 meters. And we have a height of 20 meters. So we can sub in these values. We have pi times the radius, which is 2 meters, times 2 meters, times the height, which is 20 meters. See how easy that is? So 2 times 2 is 4, and 4 times 20 is equal to 80. Now the way we write this is 80, we include the variable pi, and then we put our unit of measure. M once, M twice, M 3 times is M to the third. Okay, so that would be the way you type the answer into Jupyter. It's also the accepted answer in any mathematics class you go into. This is the more exact answer because, yes, we can round pi up to 3.14. But if you look on the calculator, I think I've shown you this before, that's way more than 3.14. So when we just use 3.14, we're getting close, we're getting an approximation, but it's not exact. This is the most exact answer because we're not limiting ourselves to a rounded decimal. Pi is a non-terminating, non-repeating decimal, meaning that the decimal places never end. So in a problem, in a multiplication problem where the decimal places never end, it's a lot more exact to use a symbol than it is to use the actual number. So this is what I want you to type in for answers. You type in the number, you type the symbol pi, space, unit of measure, the exponent button, and then the exponent of 3 for volume. Why do we use the exponent of 3 for volume? Because we have 3 units of measure being used. And each one of these is treated like a variable with an exponent of 1. And we know when we have the same variable that's multiplied against each other, we can add the exponents together, just like this. M times M times M is equal to M3. It's the same thing we have here, M3, right? And that's why we do it that way. So let's talk about surface area or lateral surface area of a cylinder. So I'm going to erase all of this because I don't want to have to redraw my cylinder because I'm not very good at it. So if you do not have this down already, rewind your video and get it down. You need to have these notes in your book. Let me get the smaller number, and I am going to erase this because it gives me a different dimension here. It gives me 3. All right. So let's talk about the lateral surface area of a cylinder. Lateral surface area. For just a minute, I want you to think about a can of soup. Let's pretend this is a can of soup and it's got a label wrapped around it, right? If you were to take that label and peel it off, right, unwrap it, the label that would come off would be in a rectangle shape. It would be. And if you don't believe me, pause this video and go to your pantry or your cabinet, wherever you keep cans, and find a can of something and peel the label off without ripping it as much as possible and see if that's not a rectangle, because it will be, I promise you. Lateral surface area is the area of that label. So you're going to need, it's a rectangle, so you're going to need a top dimension here and a side dimension here that you can multiply. Because it's a rectangle, it's going to be length times width. That's all it's going to be. So what is the length of this label? Well, if it wraps around the circle, it's going to be circumference. And we know the circumference of a circle is 2 pi r, right? And then we have, so that's the top dimension, 2 pi r. Then the side dimension is going to be the height of the cylinder, or the height of that label. And in this case, that's 20 meters here. But so circumference here is the top dimension by height here. So our lateral surface area of a cylinder is going to equal 2 pi r times height. So in this case, it's going to be 2 times pi times 3m times 20m. Now notice we only have 2 units of measure, right? 2 units of measure, and it's area. So we're only going to have an exponent of 2. So 2 times 3 is 6. 6 times 20 is 120. And then we have our pi. Then we have meters. We have meters once, meters twice, meters twice. And that is how you would write lateral surface area. How cool is that? Easy peasy. It's a lot easier than you think it is. All right. For a cylinder, 2 pi r height is your lateral surface area. And if you want to get your total surface area, you're just going to add in the area of the circle on the top and the area of the circle on the bottom. So you're going to have your LSA, right? Your LSA plus 2 times the area of the circle, which is pi r squared. So your total surface area is going to be 2 pi r h, which is height, plus 2 times pi r squared. And that will equal your total surface area, or your TSA. Now, sometimes a question will drop the word total and just ask for surface area. That's still, it could be called surface area, or it could be called total surface area. But if it's called lateral surface area, it's just talking about that label that would wrap around. It's just the sides, because lateral means side. That is the definition. In Latin, it means side. So lateral surface area is the surface area of the sides of your cylinder. All right? Please take all of these notes down. We're going to do some practice problems in just a moment. So here is, yes, here we go. Let me erase all of this. You should have this in your notes. So first of all, Let me get the right dimensions here. All right, so the area of this circle, this is 4 centimeters, and the height is 10 centimeters. All right, so we need to find the volume. We need to find the lateral surface area, and we need to find the total surface area of this right cylinder. So remember, our volume is base times the height. So we have the base, which is the circle, which is going to be pi r squared times height, right? So that's going to be pi times 4 centimeters times 4 centimeters times 10 centimeters. All right, 4 times 4 is 16 times 10 is 160 pi centimeters cubed. Centimeters to the 3. I'm going to move over a little bit more, make my letters a little bit better. So the lateral surface area is just going to be their circumference times the height. So the circumference is going to be 2 pi r times the height. So that's going to equal 2 times pi times r, which is 4 centimeters, times the height, which is 10 centimeters. So that's going to equal 2 times 4 is 8 times 10 is 80, and then we have pi centimeters, and it's once twice, so it's squared. Now total surface area, remember that. Total surface area is going to be the LSA, which is 2 pi r times the height plus 2 times the area of the circle, which we know is going to be pi r squared. So that's going to equal 2 times pi times the radius of 4 centimeters times the height, which is 10 centimeters, plus 2 times, actually, we've already done this one right here. So I'm just going to write it. Instead of trying to calculate this whole thing again, I'm just going to take it and put it in here. 80 centimeters squared, 80 pi centimeters squared plus 2 times the pi r squared. All right, so that's going to equal 80 pi centimeters squared plus 2 times pi times, we have 4 centimeters times 4 centimeters, right? Pi r squared. So it's 2 times 8 times 4 is going to be 32. So 32 pi centimeters squared. And this is 80 pi centimeters squared. So now we can add these together because pi and pi, centimeter squared, these variables match, so they are like terms. So 80 plus 32 is 112 pi centimeters squared. And that would be your final answer. And that is your total surface area. Alrighty. Let's try another one. All right, let me get this to erase this and this. All right, in this case, we have 2 inches and 5 inches. So our volume is going to be the area of the base, which is pi r squared times the height, which equals pi times 2 inches times 2 inches times the height, which is 5 inches. 2 times 2 is 4. 4 times 5 is 20. So 20, then we do pi inches cubed. That is your answer for the volume of this cylinder. What about our lateral surface area? Well, that's going to be circumference, right, times height. So that circumference times height is going to be 2 pi r times h, which equals 2 times pi times a radius of 2 inches times 5 inches. 2 times 2 is 4, times 5 is 20. This is 20 pi inches squared, because we only have 2 units of measure here. All right. So now let's look at total surface area. Total surface area is 2 pi r. It's the lateral surface area. So why don't we just write that? We'll write the lateral surface area plus 2 times pi r squared. And that's going to equal, here's our lateral surface area, 20 pi inches squared plus 2 times pi times, and that's going to be 2 inches times 2 inches. All right, so 20 pi inches squared plus 2 times 2 times 2, that's 8 pi inches squared. 20 pi inches squared plus 8 pi inches squared is 28 pi inches squared. And that would be your answer for the total surface area of this right cylinder. All right, that is all we have for lesson 73. I'll see you guys in lesson 74.